Yep. Um, we will see here how we can use the TI Nspire to help us analyze the graph following the recipe we talked about earlier. Um, so what we want is to work with the derivative, find the sign diagram for the derivative, um, so we can find where the graph of f is increasing or decreasing, and maybe also find some stationary points and describe the nature of these. So I made myself a function f of x here, and I also found the derivative of f dashed x equals 0.75 x squared minus 4x plus 1. And since this is the one we want to analyze or work with in order to be able to say something about f, this is the one that we will type into Nspire. So let's do that first. See if we can find Nspire. Here it is. So first we go to the home window, and here we will choose a graph. So we type in f dashed x here. So that was 0.75 x squared minus 4x plus 1. Better check. Minus 4x plus 1. Looks right. So here's f dashed. So what are we supposed to do? Well, let's follow the recipe. So what we did find f dashed. What we want now is to solve where f dashed equals 0. And we will do that using Nspire. And when does f dash equal 0? Well, when it has a 0, and that means when it hits the x-axis. So we can already see that there are two zeros here, but we might not be able to read them very accurately. So we want to use Nspire to find the actual zeros. And we do that by pressing menu here and choosing Analyze Graph, number 6. And number 1 is find a 0. What we do then is to mark up a left or a lower boundary, and that's a boundary that sits before the actual 0. So I'll press somewhere here, and then I'll drag until I pass the 0, and then I'll make my upper bound. So now it found the first 0 here. And is it possible to... I'll drag the label over here so we can see it. Okay, so that was number 1, and now I want to find the second one, and I do exactly the same again. 6, analyze graph, find the 0, and then set a lower bound and an upper bound. And here's my other 0. And per default, I think Nspire is set to show 3 significant figures, which is all right for us. So the two x values of interest will be 0.263 and 5.07. So we could go over to our document here and write that. So we could say that f dash of x equals 0 gives us that x is 0.263 or 5.07. I'll check my results: 263 and 5.07. So these are the x values of interest. So when you make your sign diagram, these will be the two x values you want to insert: 0.263 and 5.07. So that leaves us with 3 intervals to check. So we want to check the sign change for f dashed in these 3 intervals. We can also do that using the graph here. So actually we can see already by just observing the graph that before the first 0 here, f dashed is positive because it lies above the axis. So if you're in a hurry, you could supply the graph of f dashed here in your in your hand in or in your answer to the question, and then you can simply state that in the first interval, f dashed is positive. In the second interval, f dash goes below the axis or the x-axis, so therefore it is negative. And in the last interval here, it's positive again. So you could quite easily just state that, but then you will have to give a sketch of the graph. You could also use Nspire to calculate a value simply by inserting a point, I guess, or something. No, it's easier to trace it. So I think you'll just choose trace the graph, because that gives you some kind of cursor here, and you can control where it is by pressing the pad here. So simply choose a point in the first interval, and you can see the coordinates down here. So as you can see, that f dashed of negative 0.3 is 2.268. So you could state that in your document here. So f dashed of, I forgot already, 0.3 minus 0.3, sorry, gives you 2 point something, 268. So therefore it's, what nonsense, sorry. Try again. This equals 2.268. So therefore this is positive. And you can do the same for the other two intervals. So you can go out here now and you can go here to some point in the next interval. When x is 0.6, you get a negative 0.13. So you can type that in here. So f dashed of 0.6 is negative 1.13, which is smaller than 0, so therefore negative. And finally, you can go to the last interval like this. And for example, here in 5.4, you get a positive 1.27, sorry. So f dashed of 5.4 is 1.27, which is positive. So there's you could say, your support for your observations. So finally, you could state that f of x is growing in the first interval, and it's increasing in the first interval, it's decreasing in the middle interval here, and it is increasing again in the last. So, and f dashed, of course, is instantaneously 0 in these two values here. So therefore, we have stationary points here. And what is the nature of these? Well, using the first derivative test tells us that because of the curvature here, we have a maximum here, a local maximum, and we have a local minimum here. So finally, you need to make your statements about the increasing, decreasing intervals. So you write that f of x is increasing in, well, the first interval is from negative infinity to 0.263. And then you have to decide if you want to include it or not. Usually I include it. In the book, they do not include it. It's also increasing in the last interval here, which is from 5.07 to infinity. And f of x is decreasing in the interval from 0.263 to 5.07. And it has a local maximum when x equals, yeah, ball point 263, and it has a local minimum when x is 5.07. So that's about it, I guess. So using, if you're allowed to use the calculator for this kind of work, makes it quite a lot easier to work with this. But always remember it is f dashed that you want to sketch here, because that's the one you want to find the zeros for and find the interval values for your sign diagram. That's it.